VisMap API was pivotal for the implementation of directedness and a custom style. Our version number was updated to 3.1.0. Imports for VisMap, network view being added, presentation properties, visual mapping, and view model were added. New services were added to the start method, along with a listener for when new networks were created, and we created a default style, which can be modified. This is the method for defining a visual style. Node shape, size and color. Edge arrows, width, and color.
Hello, my name is Gabriel Zavala, and I'm gonna show you a demonstration of the code length threshold in algorithm number 3 and 4 and randomization on algorithm number 4. For the code length threshold, I created a global variable code length threshold, which has a default value of 0.1, but you can modify this to the desired value that you want. This is the global variable, and if we scroll down to algorithm number 3, which is the cluster algorithm, here you can see the threshold. Here, check if the bit length is below the threshold, and if so, it breaks the algorithm. Then, if we scroll down to algorithm number 4, which is the optimized algorithm, which is this one. Here I added a randomization. I did it by calling the collection.shuffle function from the collections API from Java, and added the node list as a parameter. It will like randomize all the nodes. Like, it will order the nodes randomly. And if we scroll down here, we find that threshold. Check if the new list new bit length is below the threshold. If so, it continues, and if it is not, it just breaks the algorithm. And I know this is just most of a backend feature. It's not gonna represent like any like design or something, but I'm still gonna show you a demonstration that is working. I'm going to SiteFinder, community detection, and I'll do InfoMap. Use weight, 10 nodes. I'm gonna create a new graph. Done, and voila, this is the graph. Thank you. I hope you enjoyed the video and appreciate your time. Bye bye.
Hi, my name is Regans, and in this video, I'm going to talk about the implementation of algorithm 5 fine-tuning from the paper Mapping Higher Order Flows in Memory and Multilayer Network in InfoMap by Daniel Adler, Ludwig Bowling, and Martin Worswell. So first, what is fine-tuning? Fine-tuning is one of the InfoMap algorithms used to optimize the modular description of network flows by allowing individual nodes to move between modules. This step refines the clustering obtained through repeated node aggregation, where nodes are initially assigned to module and iteratively move based on code length optimization. In the next slide, I will be talking about how we implemented the fine-tuning algorithm. As you can see in the comment above, InfoMap tries to move single node out of existing module into new or neighboring module. The first step of the fine-tuning algorithm is to reassign each node to the sole member of its own module to allow for single node movement. Then the second step is to move all nodes back to their respective module of the previous step, and it's called cluster algorithm 3 repeated node aggregation. So let me go over the code. So the first line is this line creates a copy of the current mapping of node to module, and stores it in previous node to module. This is done to keep track of the previous module assignment before the fine-tuning process begins. and that line, one node, one module per node G. This function is called to initialize a modular partition where each node is assigned to be the sole member of its own module. In other words, it starts with a partition where each node is considered as an individual community module. The next step is it resets the node to module mapping back to the previous state after initializing individual module for each node in step 1. This line restores the original module assignment, and at the end, this function is then called cluster, which is algorithm 3, repeated node aggregation. The detail of the cluster function would be defined elsewhere in the code space. In summary, the fine-tuning method performs the following steps. Start with each node in its own module, save the original module assignment, reset the module assignment to the original state, and apply the repeated node aggregation algorithm to refine the community structure. Thank you. That was the implementation of algorithm 5, fine-tuning in the SignFighter project. Thank you.